Okay, for people joining this live stream, this is a discussion about language development for Wolfram language, and we have a variety of topics here, including some that I think are kind of complicated and interesting. So actually, we have a pre-topic, which came that Etienne sent me over the weekend, something that he has discovered for working on a book he's writing. Hey, we're going to pre-promote your book, Etienne.
Cool.
So the idea is when you have a formula, but you see, I think you could do this for code as well. You're basically, you're making a comment. I mean, this is the modern world of typesetting with gray levels and things, which didn't exist back in the day when, millions of years ago when typeset formulas were invented, so to speak. You couldn't do gray level printing, or not in a reasonable way. So basically what you're saying is we could imagine a piece of code where we have essentially an annotation in the code or in the formula. It's a form of commenting, basically.
Yeah.
And I think it's interesting. I mean, it goes along with, let's just pull in a random piece of code. Let me just get a piece of code from somewhere. I'm sure I've got some from something I've been working on recently. Let's just pull something in here. Hold on 1 second. Here, I'm just gonna pull this up. It's not really relevant, but I'm just gonna yeah, here we go. So let's just pull in this function here. Okay, so what we're saying is, I could go ahead and I could make that map indexed. I could turn that magenta, for example, were I to want to do so. And that magentification is not going to change when I send this into the kernel, it's just going to ignore that, right? But the question is, could I put something in here where I, for example, say in this, I could put a comment, but could I also put something where I say something like this, where I put something up here that says, I mean, just to be crazy, I could put an inline cell here that says, this is the best part of the code. And then I could make that, for example, gray. And I could probably also make it, how do I make it text font? Well, here I can just say, I'm going to do anything? No, it's not. I don't know how to make that into a text font. How do I make that into a text cell there?
Alt 7 or.
Well, you think I can just do that? Okay, it did something. Okay. So that would be kind of what it would look like. I mean, no, it didn't work. It just didn't. Oh, I see. It changed it into whatever. I mean, whatever. I can change the font.
Yeah, and it could be a call out or something like that.
Yes, it could be. But the question is, semantically, what is this, right? So in other words, we could give some nice, command key, some nice way, right-click menu, something like that. I mean, this is sort of the inverse of iconization, right? So just like I could take a piece of this code and I could say, iconize that, right? This is something a little bit like iconization. Now, iconization does not survive evaluation, nor would this. Anybody want to comment on this?
This reminds me of the language captions.
It does. Yes, it does. I mean, let's look at language captions for a second. Wow, we have them in Lithuanian. That's pretty swank. I mean, I think this is quite interesting. I don't know whether it goes above or below. I mean, clearly with language captions there, it would suggest going above is better. So the question is, what would this look like in terms of the, and the other question is, if I want something that survives evaluation, how do I do that? Or do I not want it to survive evaluation? I mean, we've had a lot of trouble with comments. What's that? Go ahead.
Probably if it's, I mean, if it's part of the computation, that it would not survive. I mean, it will survive when you evaluate just by itself, but when it's like, you know, x plus 1 and you commented x, then I assume that the result will not be, I mean, a 1 plus 2 and you commented 1.
So what are you saying? I mean, look, mostly these comments disappear, right? Do you understand what I'm saying? I mean, most things about code. What are you saying? I'm not sure what you're saying.
I'm saying that it's inert, right? I mean, okay, one way I was seeing it was just an inert wrapper, and that wouldn't change anything about the computation.
But it
would just, when the expression is displayed. So I guess you're saying something a little bit different, right? Because you're saying
no, but I'm saying let's say we've got this, okay? And if I put in here, if I say here labeled 6 hello, right?
Exactly.
And it's going to look like that. But that means if I take this thing squared, then hello, you know, then that whole form is squared, right? So you have to make a decision. Are you, you know, and that's the thing which we've always had trouble with comments, because comments, you know, one of the issues is when we do transformations on code, right? The comments are just not there. So one of the things, and probably this is the wrong group to talk about this, but one possibility would be that since we've got all these hashes present, that we could actually have this be a thing that is maintained along with this code, but is not part of evaluation. So in other words, it knows, I don't know if that can be done. Maybe that's a stupid idea. Do you understand where I'm going with this? I mean, that expression can have in some hash table somewhere off on the side, it can say this was annotated in this way. Do you get what I'm saying? Anybody understand here? Right. Yes.
I think there are two methods here. One is doing it via the front end, like you did with map indexed. The other one would be to have something that, yes, it doesn't survive evaluation. It's there type setting, but as soon as you evaluate it, it's just not there.
Well, I know, but right now, all these two do not survive evaluation, right? The icon opens up, the color disappears, right?
Right, but you did them interactively, not programmatically.
That's true. That's true. I mean, Iconize has a programmatic form.
Right.
Okay, so here, if I were to say to this cell, convert to traditional form, I predict that we'll lose that color. You see?
Right.
Okay, so that's the main issue, is transformations which are made in the front end, and we probably have the wrong group to discuss this here. I mean, I think this is a good idea. Okay, we got the wrong group to discuss it. So let's put it on an agenda for another time and actually discuss it with people who, you know, the code assistance people and people in the front end group. Make sense?
Yep.
But I'd like to, I mean, I think we should call this, we can call this inline captions. Okay?
Mm-hmm.
And we should discuss it. I mean, I think for what you want here, you would be happy, I'm guessing. I mean, this is just a formula you typed in, basically, right?
Yeah, but I did with code, with old form. So I would be happy with the programmatic way of. I mean, I would also be happy with non-programmatic way, but you know, it's a bit nicer to have it programmatically.
I agree. But as we've discussed, I mean, with Iconize, we've got kind of a nice setup, because with Iconize, you can get, okay, so let's remind ourselves how Iconize works. We've got this. If I now say %, how does that work? But if I copy it, how does this work? We've probably got the wrong team here to discuss that. How on earth does that work? Because if we could make that work here, wait a minute, the Iconize did not survive conversion to traditional form. That's probably wrong. Devin, are you here?
Yes, I'm here.
So you need to make a
see
note
it.
of that.
Mhm.
And that's Etienne's.
Exactly. Yeah.
Right, and you wrote this in this form because you're
Yeah.
basically trying to write these formulas, and that's cool that you're writing these formulas in code.
I usually use old form, but the label, it wouldn't work with labeled, right? Because it would
What form?
write it
Sorry,
as labeled.
sorry,
Like,
which form?
often I use hold form just to to have the A/B not evaluating. I guess I could use strings everywhere.
You know, actually, you're teaching me something here, because the fact is, you know, in some of this physics stuff I've been doing, I've had a hell of a time because I've been entering formulas interactively, and that's probably stupid. I should just use this.
I was doing that before, and honestly, it's much better to do it with code.
Good idea, because you can then reuse pieces more easily and so on.
Yeah.
I mean, it's a little funky doing things like this.
Yes, this is not actual code. Yeah.
Well, but let me show you something and see what you think about it. This is in prototype build, I think. Somebody know how to do this? Is the tech input in the prototype build, because I think that might get the best of both worlds.
Mm-hmm.
In other words, hopefully that will turn into something. So the question: can you get out the subscript thing from? So if I enter a subscript I here.
Well, I think Subscript actually did it interactively, and this, and it's only when I copied the code that it.
Okay, so that does the right thing.
Yeah.
So I mean, I think the interesting thing here is if we go to this. So inline tech input. Okay, so here we've got, so let's say I say list, and then I say frac, X. I don't really know my tech, but I don't know what, I'm making this up. Is this correct, tech? Do you know?
Been too long for me.
Yeah, I think so.
Okay, so that's beautiful. So that then, okay, so let's put this in a list and just see what it does. Okay, so what's interesting there is it entered, it's not obvious this is correct, it entered even in this form as an inline cell. I don't think that's right, and Devin, that's for you to note. But look at this. Isn't that cool? That basically was something.
How did you start?
What's that?
How did you start? How did you start typing?
Well, I used, I mean, it's going to have a command key, but right now it's inline tech input.
Okay.
And now let's see whether this works. If I say t mu, how does this work? Do I do another? Would I say t mu? T mu new, like that. That's nice. Now, what's this going to turn into? And what the heck is that?
I guess another subscript with 2.
Right. But now if what I did instead was, so what you're saying is if I do the tech input of something like I squared, okay. I see. Oh, this is great, actually, because the primary use here, I wasn't even thinking about this case. The primary use is the tensor is, and then here I would do inline tech input. I mean, this is its primary use is for inline input, not in code. But I'm realizing from what Etienne is saying, this is also useful, right? Because this gives you a way to if you have a nice whatever it is, I'm sure there's things we can do here that are not easy for us to do. Well, and vertical bar, let's say the set, such that blah 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 blah, z colon mapping. I don't know what it is. Let's guess right arrow.
There is a maps too.
Okay, maps too. Okay, so something like this. Lovely. And that's completely meaningless for us, and we get all the spacing wrong. Because we think of this as as something meaningful to us, whereas this is just thinking of it as sort of pure math gunk, so to speak. This is great.
Mm-hmm.
I mean, this makes use of stuff that was built 25 years ago for our weird converter to from tech to boxes, which we should have incorporated in the product a long time ago. Okay, so anyway, for another meeting. All right, let's talk about array broadcasting. Okay. Well, I mean, whatever. I don't think that's the main point. The main point here is...
That's where we come from.
Yeah, I understand. Okay, so let's...
So
this isn't going to work, but...
extracted two topics. So I must say, it's a very beginning, even for us, that we think about that. We're having a meeting with Tali. Sebastian Tali has a bunch of ideas, and he wants to explore them and write a blog post about it, which I think is great because, I mean, especially for broadcasting. For the array aggregate is kind of a much easier problem.
Right. Oh, the question, sorry, just the...
Yeah.
What is this add-on for inline tech? It's coming in version 12.2 is the answer. It's not available yet.
For the tech, yeah.
Yeah, right. It's our own code base completely. Okay, sorry. Back to this.
So yeah. So I was quite happy that Tali he has been thinking about this for a long time, and he wants to write a blog post about it. And I think it's good to explore a bit, everything you could do with this concept to go beyond what other people do, because we're kind of seeing it from the perspective. Let's see what other, I
don't really care.
Exactly.
But yeah.
Try to at least match them, but maybe we can go beyond. So anyway, it's very in its infancy, at least for broadcasting. For the array aggregate, this is much more straightforward.
Okay, so let me just try to let's frame for everybody what the heck the point is here. So the issue is there is a notion of I hate the way this works, but anyway, whatever. There's a notion here of at what level does what level of aggregation occur, right?
Yeah. On what axis? Yeah. On what axis do we aggregate or something like that?
Okay. So what does aggregate mean? How does it compare to map?
So this is quite different. This is for functions that take a list of stuff and return a unique thing. Like, mean would take a list of numbers and return a scalar. So I don't think. Oh yeah, I guess map would work as well. Yeah, there. So.
Well, no, it's an apply. This is an apply at a particular level, right? So let's take this example here, right? So what you want to do, what is this in fact doing? Is this a transpose and an apply, or what is it?
This is like a map, actually. This is a map of max over these three map at level 1.
Sandro on a live stream is commenting that he asked for these level spec functions 4 years ago for things like mean and variance.
I think this, it's very useful things, yeah.
So this is a bit like flatten, inserting some operation in the middle. So before you construct the new array, you are allowing yourself to do something with the vectors, something like that.
Boy, we should be looking at this. We should have discussed this more actively. And then probably we've gone through some of this, but it'd be good to have more discussion of this. I hope. Yeah, Devin, that's another thing for you, please. Can we make sure we process this and see what should be on these agendas if it hasn't been already? Okay, so I'm sorry. Go ahead. What were you saying here?
I was trying to compare this to flatten, which is another operation that kind of destructures array. But of course, it does nothing in between.
Right. So tell me what the definition of this thing is in terms of, I don't care that it works the same as aggregation layer. It's just super confusing. Just explain what this thing does in general.
All right. So you basically, the third argument is a list of axes on which the array will be, I don't know, contracted, aggregated. So
talk tensors for a second. What would this be in terms of tensor indices? What is this doing?
Well, I'm not going to be very good at this language.
Jose, can you?
Yes, I think this is trying to.
Boy, physics is so micro. You see, Etienne. Right. Okay. Never mind.
Yeah, I was never, this type of physicist.
Okay. Anyway, go ahead.
I think this is trying to generalize the second argument of flatten, which is super powerful, to other functions. The idea that you can say, take levels of the array and create a new array with new levels, which come from the previous one in this way.
Okay. I mean, I remember it took years to come up with that second argument of flatten, the full second argument of flatten. I remember working on that for a long time. Okay, so let's see whether it is exactly the same as that second argument of flatten. Whether what this is essentially an apply flatten type construct. That it is. Go ahead.
Yeah. I guess that's kind of what it is. Yeah. I mean, kind of a flatten is doing a bit of transpose as well, right? That's the idea.
Transpose is a particular case of flatten. Yes. So flatten is flatten with the second argument it has, which is so powerful. The last version, that's incredibly powerful.
So, okay, by combining all levels Sij to make each level I in the list.
Right. So here you start with an array with many levels, and then you are going to take several levels and construct a new array with combinations of these.
Exactly. So the only difference is that what flatten is doing is it's doing the null operation, so to speak.
Exactly. It's doing nothing with the elements.
Right. So in general, what one's talking about is doing something where one is performing an operation so one is on this sub array, one is doing an operation. So Sandra is commenting that total has a.
Yeah, total has one. Yeah, you cannot have. Although it's level 1, N1 through N2, which in our case, the list would be for level N1 and N2.
Right.
And you would need a span to say n1 to n2. So it's adding.
Well, I don't even know for total whether that aggregator, whether it's aggregator, I don't quite understand what it would do if you give two disjoint levels. Does that make sense for total? Help me out here with
yes. Okay. Let's think in terms of dimension. Look at the last example, just in terms of dimension. A aggregate dim of 3, 4, 5. Okay, if you just put a 2, what it's doing is that it's kind of, you can see that as a transpose, I guess, on this case. Like the 4 would be put, 4 and 3 would be swapped, and then it would do a map. You could see it like that. I mean, not a map, but it would do the mean on the first level.
You're saying, okay, so in terms of sort of the skeleton of a tensor, this is a 3, 4, 5 tensor, 3, 4, 5 array, right? And what you're saying is, if I say mean it at level 2, then what I get back is a 3, 5 array.
Exactly.
But let me understand what that means for the deeper levels here, because let's say I make an array. Okay, let's make our 3, 4, 5 array. Okay, so let's just say, I don't know, subscript. Let's just to make it a little bit more readable. How do I do this? Can I just do hash there? 3, 4, 5. Okay, there we go. Okay, so there's our 3, 4, 5 array. Okay, now what does it mean to mean it at level 2?
Right. So yes, this is something I have investigated in the past. So the idea here is that not only you have to say at which level you are applying mean, you also have to say how do you treat the elements you find at that level.
Exactly. How far down do you just pick up? So if I were to take level 2 of this, right? So let's take this thing at level 2. Okay, so what is that? That is the level 2 subtensors of this subarrays of this thing. And so then what I would be doing is I would be meaning each of these. So I'd be mapping mean against each of these. Is that correct?
I mean, mean is not doing at level 1 by default, so it's going to be weird.
Okay, so then let me not use mean then. Let's just use F.
I don't think it.
Okay, so there I've got that. So that means that is saying at level 2, you're saying this is an applying the operation at level 2, which is something I could just do with apply.
No, I'm not sure. Wait.
Yes, in this case you would map mean.
Yeah, right. It will be a map. So this is equivalent. What I got there is equivalent to saying on the original array.
You should also put level. I think it's in bracket, curly bracket. No level to have only 2.
But there isn't a meaning to that. Look. If I say 296 here, the whole point is. Wait a minute. Now I'm even more confused. Why is that different?
This is level 1 through 1 and 2.
Oh, I got it wrong. Okay, I got
level 1 and 2.
Yeah, I got that wrong. Okay, I got that wrong. Okay, so there's the result. Okay, so what this is saying is that is the equivalent of saying map on map of F onto %296 at level 2.
Right,
correct? Yes?
Level 1 in this case.
Why was it
What
level
is the
1?
dimension of that? What is the dimension of that?
345. 296 is dimension.
And the result? Yeah.
Oh, the dimensions of the result.
I mean, if the result is 3.5, I would say yes.
No, it's going to be 3.4 in this case.
Then that's not good.
How do I get it to be 3.5? I can't get it to be 3.5 because this thing.
Map at level 1. Map at level 1.
Why would that be 3.5? Why isn't
that? Not in this case. With F, there is no way to do it. With mean, it would work.
Why?
Because mean would be able to take the mean of a list of vectors.
Oh, I see. Because mean returns something, because mean has a sort of pseudo listability, it will return something of that with that shape.
Right. So the question here is that there are functions that will do different things depending on how they treat their elements. And the most famous case for us is outer. That's why outer needs these integers at the end.
Yes.
So I call these effective ranks. And so we have functions that deal with arrays, they might be doing things differently depending on how they treat their elements.
Okay. So you're saying there are different cases, functions that, to use a term that we used in version 1 design, rodentify. That is, they drill into they burrow through an array, versus, and I can't use that word, it's too stupid. Functions that burrow, basically. Well, they're different cases. How do functions treat a list? Right? They could be listable. They could essentially auto map, i.e. be listable. They could do the kind of thing that mean and total do. They could be auto apply at level. Auto apply. What is it doing? It's what is the correct thing? It's doing auto apply at level 1, right? I think that's right. Am I right here?
What do you have in mind? Which function are you thinking
Well,
of?
I was thinking of total, right? So total of A, B, C, D will give us AC plus B plus D, which is otherwise known as saying apply F to this thing. No, it's not doing that at all. It's doing some kind of transposed. That's doing the kind of thing that this aggregate function is thinking about doing, so to speak.
Well, it's applying plus at level 0.
Hold on. Where am I going? I'm going to put this under functional programming. That doesn't really belong there. You know what? Let me put this. Let me do something different here. Let me make a separate notebook. Devin, do you have? You know, we really should prepare for these things, where we expect to put the notebooks that we create. Okay, let's say array aggregation 01. Okay, let me move this stuff over. Okay, well, we could just say, okay, here. Okay, so the first question is, how do functions, you know, from the beginning treat a list, so to speak? Like total does that thing, but that's very different from what a listable function like log here would do this, right?
Yeah, which is not a contracting, I mean, not an aggregation function.
I'm sorry?
It's not an aggregating function log.
Right, but this is doing some kind of aggregation. Sandra
Total
is recommending that we try a few examples here, and I think we should. I'm sorry, I'm going to replace this with ABCD so that I don't have to do arithmetic in my head to understand what's going on. Okay. So at level 2, what I would assume is this is going to give us A plus B, C plus D. Yes. Down to level 2, I would assume it's going to give us A plus B plus C plus D. The whole ball of wax. Okay, good. And what I would assume the default is the default, I think, is this level 1 thing. Am I correct?
Yeah.
Yes. Okay.
So what we propose is an extension of that. So all of this are still there, actually, except the 2 that's going to be a span.
Right. Okay. So let's try to understand what you're suggesting here. Yeah. Meanwhile, I also want to understand. Okay. So flatten here at level 2 would do absolutely nothing. What?
Well.
What did that do?
Flatten requires either a number or a list of lists. The case of a list, I'm not sure is always well defined. You can flatten two levels, or you can use the list of lists notation to specify a mapping of levels to levels.
Right. So if I were to say here, flatten,
You can
and
say
then
flatten.
pair 1, 2 like that. That should do a complete flattening.
Right.
If I were to say flatten 2 to 2, I don't think it does anything, does it?
No, they cannot be repeated. The numbers cannot be repeated.
Okay.
But you can do 2, 1, and then there will be an effective transpose before. Or
Right,
you can
because it's putting.
Right. It's first transposing and then flattening.
I see. Okay.
Or you can do list 2, list 1, and that's a true transpose.
Okay, so I understand that. So that will put level 2 at level 1 and level 1 at level 2.
Exactly.